Hello students, in this video we'll complete the remaining NEET 2025 question paper solutions, and in this 36th question up to that previous videos we presented, and this video we are going to complete from 37 to 45 questions will complete. Now look at the question given. A sphere of radius r, the given, this is the one of the sphere of radius r cut from the largest solid sphere of radius to r. This is the one of the sphere given, the sphere having radius to r. From that we taken a portion of sphere of radius r as shown in the figure. This shaded one, from the shaded one, unshaded one we remove. The ratio of moment of inertia of the smaller sphere, this is the smaller sphere, the moment of inertia of this one is taken as I, and to that rest part of the sphere, that means if you taken smaller sphere moment of inertia as I, if you say, after removal of this one, the bigger sphere appears to be like this, the bigger sphere will be like this. Now this sphere moment of inertia they are asking. Rest part of the moment of inertia about y-axis. Y-axis means this is about this axis. So the smaller part moment of inertia about the y-axis they are asking. About y-axis. So you take the smaller part is I1, you take it. The remaining part which you have, the moment of inertia of this one is you take it as I2, you take it, right? So first when you taken, this is I is the moment of inertia of this small body. The body, the sphere, it is a solid one, so mass is distributed in terms of volume wise. So to calculate the moment of inertia, you know that moment of inertia formula for any body which is rotating about its own axis is, that is 2 by 5 mr square is a formula for that. So m is the mass of that one, so you need to find the mass of the remote portion, mass of the actual sphere, like that. That's why we need to calculate the mass here. So first what I'm doing is I'm taking the, without removal of the portion, I'm calculating the moment of inertia of the original sphere. So to find that one, first the mass particles are distributed here. What way the mass particles are distributed? The mass particles are distributed volume wise, so that is called volume density, volume mass density. The volume mass density is equal to mass occupied by unit volume. So mass equal to nothing but density into volume. So what is the volume formula? This is spherical body, that is 4 by 3 pi r cube. But radius of the bigger sphere, what is the radius of the bigger sphere? The radius of the bigger sphere is 2r. So we are taking this as 2r whole cube, because formula is 4 by 3 pi r cube. If you calculate this one, you are going to get m is equal to, that is rho into 4 by 3 pi r cube into 8, because 2 cube is equal to 8. This mass of the original sphere we got it. Next, calculate the mass of the remote portion. Which is the remote portion? This is the remote portion, right? So what is the radius of that one? Smaller. So original sphere is capital M. If you say the small part which you remove, the mass is small m, you take. So to calculate the mass of this one, the mass equal to, according to basic concept of this, mass equal to volume into density I can write. So density into volume of the smaller portion, that is 4 by 3 pi into radius of this one. What is the radius of this one? The radius of the smaller sphere is r. So I can write as simply r cube, because 4 by 3 pi r cube is a formula. Now compared to this, write this small m in terms of capital M. So what is rho into 4 by 3 pi r cube? Look at this one. In this case, if you observe this one, this is rho into 4 by 3 pi r cube. This rho into 4 by 3 pi r cube I can write as 8. If you bring it this side, it becomes m by 8. Yes or no? Now you take that value. That means rho into 4 by 3 pi r cube value becomes m by 8. So the small m value is equal to nothing but, compared to actual mass, is 1/8 of the mass we removed. This is the one concept you got right now. So what is the moment of inertia of the original sphere? If m is the mass of this one, capital M, then what is the moment of inertia of its own axis? Moment of inertia of any body about its own axis is, that is 2 by 5 m r square is the formula here. So here I am taking this, I0 I am taking, because original moment of inertia of its own axis is I0. I0 is equal to 2 by 5 mr square we can write. So after substitution of this one, So what is the mass of this one? You can take it 2 by 5. Mass is m, radius is nothing but 2r whole square. This I can write in terms of, this we can write as 8 by 5 mr square. This is the moment of inertia of the original sphere without any removal of portion of mass. Now, what is the moment of inertia of the sphere which you removed? This is the part which you removed of radius r. So that I am taking as I. So I is equal to, that is nothing but, we can write 2 by 5 small m into radius of that is r square. But this small m I can write in terms of capital M as 2 by 5 into capital M by 8 r square. So what is the moment of inertia? I is equal to, that is 2 by 40 mr square unit. Now what the question they are asking, the ratio of moment of inertia of the smaller sphere to that of rest part of the sphere about y-axis. About one axis, that means I am taking in red line of the axis. This is the one axis of the original sphere. The moment of inertia about this one is we taken as I naught, and this is the small sphere which you removed. The moment of inertia of this one about its own axis is we taken as I. Now we require that this moment of inertia, that means this sphere which you removed, this moment of inertia I with respect to y-axis we want. That means if you see the red color axis, these two axes, that means the moment of inertia of the one axis of this smaller sphere is exactly parallel to the actual axis of rotation, that is y, parallel. So you have to apply the parallax theorem to find I1 value. So I am taking that one as I1 is equal to, use the parallax theorem. What is the parallax theorem? Moment of inertia of the smaller sphere about its own axis. What is the moment of inertia of this own axis? That is I. So I can write as I plus small m, because this mass is small m, into square of the distance. What is the distance between these two parallaxes? That is small r. If you taken, that is nothing but small r square. Now if you solve it, what you are going to get? This is I1 is equal to I. What is I value? Just before we calculate, that is nothing but 2 by 40. 2 by 40 mr square is the original value, plus small m. What is the small m value? That is nothing but capital M by 8, already be done, into r. What is the radius here? Sorry, not radius, distance between the parallaxes. From here to here, what is the length? That is 2r. In that, what is this length? R. 2r minus r will get r. So simply I can write as r square. So if you solve this one, what is the I1 value you are going to get? I1 value about y-axis is equal to, we will get, so 40 is the LCM I can take. 40 is the LCM we can take, or you just take it. This is we'll get 40 into 8. If you take an LCM here, that is 16 mr square plus, that is 5 mr square. So this value I1 is equal to, using parallax theorem, that is 21 mr square by, that is 40 into 80, that is 320 you are going to get. Here if you check it, there is a small error here. That is, what is the LCM? We won't get 40 into this, we will get 40 only. The LCM we are going to get 40 only. So if you taken as the LCM is 40, that means 2 mr square, sorry, this is 8 mr square, 40 means this is 2 mr square you get, plus 5 mr square you get. That means this value you are going to get 7 by 40 mr square you get. This is called as equation number 1, right? Next, we got the moment of inertia of the small one about y-axis. Now what is the moment of inertia of this removed portion? That means remaining part. This is remaining part. The moment of inertia of that one about its own axis I2 value we need. To get this I2 value, remaining portion, so actual original sphere moment of inertia is what you taken I0. The removed portion moment of inertia about one axis is we taken as how much? I1. So I want I2 value. I2 value want means total moment of inertia minus you remove this moment of inertia, so that I2 value is equal to, we can get as I0 minus I1. gives the I2 value. So we are going to calculate the I2 value now. So how to calculate the I2 value? I2 is equal to nothing but I0 minus I1. Check the I0 value. What is I0 value? Already we done here. This is 8 by 5. 8 by 5 mr square minus what is I1 value? I1 is equal to 7 by 40 mr square. You solve this, what you are going to get? 8 by 5 mr square minus, okay, this 40 is the LCM if you taken. Then now we are going to get this one as, okay, 64 mr square minus 7 mr square. So this is I2 is equal to nothing but 64 minus 7, 57. 57 by 40 mr square. 57 by 40 mr square. This is called as equation number 2. Now our required question is, what is the ratio of moment of inertia of the small sphere to the remaining part? That is I2, I1 by I2 about y-axis. So what is I1 value? Just we got, that is 7 by 40 mr square, right? In the denominator we have 57 by 40 mr square. Now this mr square we can cancel. Okay, we taken this one, this mr square can cancel, 40 cancel. So answer for the question, I1 by I2 is equal to how much we got? 7 by 57. This is the answer to the question. So if you check the options of this question, so what are the options we have? We did not have options. When just we'll check the options of this question. So here the options are given. First option 7 by 8, 7 by 40, 7 by 57, 7 by 64. So which option correct? Third option is correct for this question. This question from semiconductor physics, that is full wave rectifier concept based. They given one of the full wave rectifier and applied voltage, they given input voltage source, that is given 220 sine 100 pi t. Variable voltage source is given. Using this, they are asking, then at time t is equal to 15 milliseconds, which diode, what is the condition of the diode? D1 is forward bias, D2 is reverse bias, like that, which will be forward, which will be reversed, or both will be forward, like that the question is. First we need to understand that when 15 milliseconds takes place, which, okay, what pulse is reaching to the diodes. That means whenever the, you know that AC source is traveling here, positive pulse, negative pulse will be there. Whenever the positive pulse reaches to the circuit, then this will be on condition, this will be off condition, right? So when negative pulse enters, then after what happens, it becomes off, it becomes half, and below will becomes on. So we need to identify that. So what is the time period of this cycle? That means, because according to given source of EMF, so we can calculate the time period, how much, what is the time, okay, for cycle, time taken first to generate the positive and negative cycle. For that, you come across a comparison of this one with the standard equation. V is equal to, it is in the form of V naught sine omega t form. So in the place of omega, what we have, in the place of omega, we have 100 pi is there. So omega is equal to, we know that 2 pi by t we can write. Omega is equal to pi by t, that is equal to 100 pi we can write. So pi get cancelled, this is 50. So time period of this cycle, okay, AC cycle is equal to how much we are going to get? 1 by 50. 1 by 50 means that is nothing but, we can write as 0.02 seconds we can write. That if you can write in terms of 20 milliseconds we can write. How much? 20 milliseconds. So time period is 20 milliseconds means if you taken any input source, this is total time for this one cycle, it is created by the source is equal to how much? 20 milliseconds. If it is 20 milliseconds from here to here means for the half cycle, how much? 10 milliseconds. But our question is given what time? 15. 15 means somewhere in between here. At this point they are asking 15 milliseconds. 15 milliseconds means which pulse is reaching? This is positive pulse, this is negative pulse. Now this, okay, full wave rectifier receiving the negative pulse. When the negative pulse is received, what happens first? When positive received, diode will be on, and this D2 will be, D1 will be on, D2 will be off. But when negative cycle is enters, okay, so in this case D1 will be off and D2 will be on. So second diode, that means D2, okay, will be forward bias and D1 will be reverse bias. So D1 is reverse bias, D2 is forward bias. This is the option. We can check it from the given four options. Okay, good. So the answer to the question is second option. This question from the thermodynamics, they given two systems, system A, system B, and both are having radius RA, RB, and here they're asking to find the ratio of RA by RB. Now what condition? Condition is we are giving the same amount of heat to the gas system here, and both are having same change in internal energy. The system sizes may be different, but the change in internal energy is okay same, and the change in amount of heat which we are giving to the system also same. Using this, if we are moving the piston, that means look at here, they given very clearly the A and B displaced by 16 centimeters and 9 centimeters. The pistons of the gas, if it is moving. So in this case, if we are moving this one, okay, through a distance of 16 centimeters, if we say this is, if we are moving this piston through 9 centimeters, if you say, they're asking the ratio of RA by RB. In this case, delta UA, UB is same. So first, according to heat, whenever the heat is given to the system, according to thermodynamics equation, that will be utilized to some amount will be delta U, and remaining is utilized to do the work. So both the cases, Q is same, delta U is same. So that means I can say work done in the case of A system is equal to work done in the case of B system. Both are same because Q is same for the both. Only difference is work. So work done also will becomes equal to same because both the cases it will be same. So WA is equal to WB. So in this case, what is work done? Work done by the gas. Whenever the piston is moving through 16 centimeters, 9 centimeters, there is a work done. Work done is equal to pressure into change in volume. We can write this is also pressure into change in volume. This is volume of the A, change in volume. This is the volume of the B. So here in the question also they given under the constant pressure. That means the pressure is also constant. And the pressure is also constant. What is that? Change in volume of A is equal to change in volume of B. So what is volume? This, okay, system contains area of cross section and piston. So area into length gives the volume. So both are okay having same area of cross section, like because this did not given that different sizes of that. So A into how much length we moved the piston, that is length of that one I am taking as here. According to this one, I moved the, okay, that is through a distance of XA unit. A into XA is equal to A into XB. This is the volume of A and B. So anyway, both the sides area is same based. We are doing this one. No, I think they did not discuss any area, right? So we should not cancel like that. Okay, so we cannot cancel, but they are asking the ratio of radius. To find the ratio of radius, convert this area. Area is equal to what is the formula? Pi r square. Right? Use that one. This is pi into RA square XA is equal to this is pi into RB square XB. So pi get cancelled. So we need to get RA by RB ratio, RA by RB whole square is equal to, that is XB by XA. First I am writing a relation. Then after RA by RB is equal to, we can write as under root of XB by XA. I can write under root. So what is the value of this XB? According to given option, XB value is 9, XA value is 16. So that means RA by RB is equal to how much you are going to get? 3 by 4. So if you check the options of this one, the 4 by 3, 3 by 4, 2 by root 3, root 3 by 2. So second option is correct for this question. This question from units and dimensions, percentage error question. So they given one of the relation P is equal to, that is A cube B square by C root D. So they are asking the percentage error in the grade and the P value. If percentage error in the A value separate is 1% and B value is 3%, C value is 2%, and last D value is 4%. So you know the formula for this one, percentage error delta P by P into 100, okay, is called percentage error. In this case equal to A value raised by 3 times, so error also repeated 3 times, that is 3 times of delta A by A into 100 plus b value raised by 2, so error will be repeated by 2 times, that is 2 into delta b by p into 100, plus c value power is raised by nothing is there, means 1 here, so 1 means error will be repeated 1 time, 1 into delta c by c into 100, plus because error always additive, so in this case d root d means d power 1 by 2, 1 by 2 means the power of the d value is 1 by 2, error in the d value delta d by d into 100 percentage error. So substitute the values here, that is nothing but 3 into delta a by a into 100, that is called percentage of a value, that is 1%, that is 1%, okay, plus and 2 into, this is second value, 2 into delta b by b value how much, 3%, and plus delta c by c value how much, 1 into delta c by c 2%, that is 1 into 2%, okay, plus last one is half into delta d by d into 100, how much percent, 4%. To solve this one, we are going to get this value totally 3 plus 6 9, 9 plus 2 11, 11 plus 2 13, this is 13%. So percentage error in the p value in terms of percentage how much, 13% you get. So which option is correct, you can check the options given, that is third option is correct for this. Now this question is from the physical optics Polaroid concept. They given the, okay, the intensity of transmitted light when Polaroid sheet is placed between the two crossed Polaroids at 22.5 degrees, means this is one Polaroid, this is another Polaroid, both are crossed means what, initially this is arranged at theta is equal to 0 degrees, what is the axis, this is called axis of the Polaroid, 0 degrees, and this is the last Polaroid which is an angle 90 degrees, these are called cross Polaroid, and we taken one of the Polaroid sheet and placed between two crossed Polaroids, that means this is one Polaroid, this one and two, these are two are crossed, in between we are placing one more Polaroid here, this is the way you can place one more Polaroid here. What angle it is made, it is 22.5 degrees, we place the one of the Polaroid between the two cross Polaroids. Now polarization axis of the Polaroid is given, I naught is the intensity of the polarized light, what is given, I naught is called intensity of the polarized light after passing through the first Polaroid, this is the first Polaroid, after passing through this one, this intensity value is given as I naught. So actually practically if you come across, this is the I naught means this becomes I naught by 2, okay, in the theories we learned, but here already they given the I naught value only, they given as I naught. So in this case, when the light passes through the first Polaroid, the intensity is I naught, after passing through the second Polaroid, this is the second Polaroid, the intensity you take as I1, and after passing through the final Polaroid, that is I2, okay, so final Polaroid you can take it as I2. So you know that according to Malus law that I1 is equal to nothing but I naught into cos square, okay, cos square theta is the formula for this, right, cos square theta is the formula. So what is the value of this one, I1 is equal to I naught into cos square, what is the angle between the first Polaroid and second one, this is the first one and this is the middle one, what is the angle between these two, this is 0, this is 22.4, difference is that is 22.5, that 22.5 we can write like this, okay, that 22.5 I am writing as 45 by 2, okay, because we know the cos 45 value, that's why we taken like this, okay, this is equation number 1. Similarly this intensity I1 after passing through the second Polaroid, it final intensity will becomes I2, that I2 is equal to I can write as I1 into that is cos square, this is the value of cos square, that is cos square, this is also cos square, and this is we can write as the angle, what is the angle here, that is important for understanding here. In this case this is 22.5 and this is the angle 90, so what angle it makes, what is the difference between the angle these two, 90 minus remaining angle, that remaining angle is called 90 minus 22.5, you have to take, that means in this case I can write as 90 minus that is 45 by 2, we can take it. So this is equation number 2, and solve the equation number 1 and 2. So what we can solve it, I will solve it, I2 is equal to what is I1 from the equation number 1, you put it that is becomes I1 into cos square 45 by 2 into, and again cos square 90 minus 45 by 2 you get. So cos 90 minus theta, we know that as a sine theta. So I can write as this one I1 into cos square 45 by 2 into, this becomes sine square 45 by 2. Now, if you observe this one, I1 cos square 45 by 2, this is. Now here, the 2 which you taken outside, this becomes I1 is equal to, already we know that I0 cos square theta, right? So I1 only we replace, this is I1. The I1 is nothing but I0. I0 cos square 45 by 2, this you are going to get. Again, we have 1 and no. So this is I0 by 4, you take it common. Okay, 2 taken common, it becomes cos square 45, and again we are going to get sine square 45. So here we cannot do it like this. In this case, if you observe this formula, so to solve this one, first what you are going to do is modify this equation. What way I can modify? Multiply and divide with 4 by 4. If you multiply and divide, this is 4, and that multiplied value I am writing as 4 cos square 45 by 2. 4 cos square 45 by 2 we can write 45 by 2 into sine square 45 by 2. Right? Now solve this one. In this case, it is looking like 2 sin a cos a form we can write. If you write in the form of that one, 2 sin a cos a is equal to sine 2a. So I2 is equal to, this becomes I0 by 4 into, this we can write as in terms of okay, 2 sin a cos a form if you written, that is 2 times of sine 2a, that is becomes 2 times of 45 by 2 you get 2 sin a cos a based. Now what I can cancel here? I can cancel here, okay, to get cancelled. Yes, here this is in the form of sine 2a. Sine 2a formula, what is the sine 2a formula? That is nothing but 2 sin a cos a. 2 sin a cos a. So this is, if you convert this, it is already 4, I can write as 2 square. So that means this totally I can write in terms of this we won't get, okay, this one. In this case, the formula if you convert, that is sine 2 into 45 by 2 square you will get. That means here if you write this formula will becomes I2 is equal to I0 by 4 into, this becomes sine square, this 2 to get cancelled, sine square 45 becomes after solving. So what the value of sine square 45? I2 is equal to nothing but I0 by 4 into sine square 45. Sine 45 is 1 by root 2. 1 by root 2 whole square means 1 by 2. So I2 value is equal to I0 by 8. The final intensity which you are receiving after passing through the 3 polarized is equal to I0 by 8. If you see the options, which is the option correct? If you see the third option, that is I0 by 8 is the correct option. This question related to spring mass system. 2 identical point masses given, that is P and Q, whose spring constant are K1, K2, respectively, oscillates vertically. If their maximum speeds are same, what is same? Maximum speeds. You know that maximum speed of any oscillating particle or spring system, P is equal to A omega, where A is called amplitude, omega is called angular frequency. The ratio of AQ by AP they are asking. What is A? A is called amplitude. Amplitude of the Q by, okay, P they are asking. That means here, so just you can take what is same here, both the cases. Here what is same? Both are having same speed. Same speed means the speed of the P is equal to speed of the Q. So the speed can be written as A omega, maximum speed concept. That is, if you apply this here, acceleration of the, amplitude of the P to the angular velocity of the P is equal to amplitude of the Q to the angular velocity of the Q. So they're asking the ratio of AQ by AP. So AQ by AP is equal to, from this I can write as AQ by AP is equal to omega P by omega Q. What is omega? Angular frequency, but we need to express the answer in terms of K. So K1, K2. So how omega is related to K? So you know that omega is inversely to time period. So I can write this one as in terms of time period related to Q by timetable related to P, because omega is equal to pi by T. So this is a relation. Next, we know the relation T is direct inversely proportional to square root of K. In the case of mass, spring mass system, T is equal to pi root m by K in that case. If you apply this condition here, that means in this case, this is becomes under root of Kp by Kq. So amplitude of Q by amplitude of the P is equal to under root of spring constant of the P. What is spring constant of the P? P value spring constant given as K1 and Q value spring constant given as K. So answer for this question is under root of K1 by K2. Which option is correct? If you see the options, fourth option is similar to this, under root of K1 by K2. So fourth one is correct. This question given from the sound topic. A pipe open at both ends has fundamental frequency F in air. Now if the pipe is dipped in vertically into the water drum to half of its length, the fundamental frequency of the air column now becomes, here this is the length of the pipe. We take an open pipe both the ends, the length is L. In this case, the frequency of this one is equal to open pipe frequency fundamentally is F. The fundamental frequency formula, we have to know that is V by 2 into L. This is the length of this. Otherwise, if you want to take this one as L naught, the length is L naught, I can take it. Now, the same pipe we are immersed into this. How much length? We immersed up to half, L by 2. Now, when it is filled with liquid, when it is immersed in the liquid, what happens? It acts like a closed pipe. When it acts like a closed pipe, now the fundamental frequency of the closed pipe, how much they are asking. So, fundamental frequency of the closed pipe formula is nothing but V by 4 times of length of that closed pipe. This is one. And open pipe formula, that is fundamental frequency of the open pipe is equal to V by 2 times of length of the open pipe. So they're asking the frequency of the closed pipe in terms of F. Okay, initial fundamental frequency, that is F, F naught based. So divide both the equations, it becomes Fc by F naught is equal to, if you taken the ratio, this becomes 2 L naught by, that is 4 LC. So in this case, this is nothing but 2 L naught by 4 into, what is LC? Closed pipe length. What is the closed pipe length? The length of the closed pipe is equal to LC is equal to how much? L by 2, half of the original length. What is the original length? We taken L naught, that means in this half value, that is half. So I can write this one as L naught by 2, you can take it. Original length is L naught in that half value. So here I can cancel, this is 2 to cancel, again 2 to cancel, L naught cancel, becomes 1. So closed pipe frequency is equal to open pipe frequency. That open pipe frequency value is equal to F. So the frequency in this closed pipe will be remains same. So option for this question is, second option is correct. This question comes from the mechanics one, that is circular motion concept. A bob of heavy mass, this is the one of the heavy mass body is given, and suspended by light string of length L. The length of the string is given L, and this is given horizontal velocity. We move this one, push this one with a horizontal velocity V naught, as shown in the figure. If the string gets stuck at the point P, at this point, what happens? It is slack. Slack means what? Loose. That means where the tension in the string has to become 0. At this point, tension is becoming 0 at this point they given. So it is making an angle theta with the horizontal. This is the horizontal, and it is making an angle theta with the horizontal. The ratio of speed V of the bob at point P to the initial velocity. Initial velocity V. At this point, the velocity is taken as V. Initial is V naught. At that point is V. So they're asking to find the ratio of speed of the bob at that point V to the initial velocity V naught. V by V naught value they're asking to find. So first you need to understand the diagram here. So here, if you from the diagram, initially the mass is here. So given initial velocity V naught, so it is having energy according to the position of this one. So this point I am taking as a point, like when it reaches to this point P, at this moment, this is the way you can see the mass body. So when the mass body is here, I can say here weight of the body is acting vertically downwards mg. So now according to geometry, what happens? It is make an angle theta here. If it is theta, means this angle will becomes 90 minus theta. So if you mg is resolved into components, what happens? You get the one of the component here that is in this direction, that is nothing but mg, okay, mg cos 90 minus theta. Now whenever the body is moving in circular motion, at this point it is having velocity, so there is a concept of circular motion we can apply. So this mg is cos 90 minus theta, providing the centripetal force. We say there is a centrifugal force is going to act, that is mv square by r is nothing but radius. In this case L is the length of that one, that length is the radius here, right? The length, because L is the length of the string which is suspended. How much length is there, that much radius it is going to generate. So why I am taking this one? Because you have to know the concept of circular motion here. So apply the conservation of energy concept here at A point and at P point. If you apply the conservation of energy, total energy at A point is equal to total energy at P point. You take it. So what is A energy? It is only having kinetic energy at this initial position, half mg naught square is equal to, when it reaches to the P point, it is having two energies, kinetic energy that is half m, velocity at that point is v square, plus potential energy nothing but mgh. What is h? Height. So what is the height of this bob? This is the body from position here to here. This is the length we get. So from here to here the length is L. Already you know the length of the string, and this length if you calculate using geometry, that you are going to get, that is L sin theta here. So not L sin theta, that is you are going to get L cos theta here. So this is you are going to get L cos theta. So if you solve this one, I think it is L sin theta or L cos theta. It is L cos theta sin theta. You are going to get L sin theta, not L cos theta, that is L sin theta you get here if you solve it. Okay, that I am writing here because every solution will take a long time. That's it. So this is mgl. I am taking common here because this total length is become L plus L sin theta. L taking common, that becomes 1 plus sin theta. I can write here. Now if you solve it here in this, I can cancel the mass both the sides here. After cancelling the mass, this we can write as v naught square by 2 is equal to v square by 2 plus gl into 1 plus sin theta here. So here answer, they are asking the ratio of v by v naught. Here v naught, v is there, here v naught is there. To get the ratio, first you have to convert this gl. So options are not given in terms of gl, that's why you have to remove the gl. How to remove the gl? You observe this concept here. This is the one of the concept I can take it. mv square by L, called centrifugal force acting on the body at that point P to away from the center, and towards the center mg cos 90 minus theta is acting. So that means I can write according to at this position. So mg sin theta cos 90 minus theta becomes sin theta. Mg sin theta is equal to mg square by L at that point of P. So get cancelled from this. I can write as L cross multiply L into G sin theta is equal to, you get V square. So that means GL is equal to what I can write, V square by sin theta we can write. V square by sin theta. Substitute that value here in this equation. If you substitute the value in this, so what you are going to get, this is V naught square by 2 is equal to V square by 2 plus GL value we can write as V square by sin theta into, I am opening the bracket here, plus directly this is V square sin theta by sin theta. So we can cancel the sin theta here, and here this equation will becomes V naught square by 2 plus V square by 2 plus V square. How much that becomes? 3V square by 2, that is becomes 3V square by 2 plus V square by sin theta. Which one? This V naught square by 2 is equal to, right? Now solve it. What is our requirement? Take the V square common from this. If you take on the V square common, what you are going to get, that is becomes 3 by 2 plus 1 by sin theta. So this 1 by sin theta I am writing as, that is 2 by 2 sin theta I am writing. Multiply and divide with the 2. If if you do it like that, then what happens, I can take the 2 common here, 2 common, I can cancel both the sides, right? So this is nothing but V naught square by 2, V naught square by V naught square by 2 is equal to V square into this. So I can write this one, V naught square by 2 is equal to V square by 2. 2 I am taking common, and in bracket I can write as 3 plus, that is 1 by, sorry, not 1, that is 2 by, denominator we have 2. So that is 2 by sine theta. Remaining we taken common already, right? So in this case, this 2 get cancelled. So our requirement is V square by V naught square. That means I can write V square by V naught square is equal to V square by V naught square is equal to 1 by 3 plus 2 by sine theta. Now if you solve it by taking LCM of this one, I can write this one as sine theta by, that is 3 sine theta plus 2 you get. And if you write the solution for this question, so what I can write this one in terms of solution based, V by V naught is equal to square, make it that side becomes root. It becomes root means that becomes, I can write as sine theta by 3 plus, sorry, 3 sine theta plus 2 whole square means the square, if it went this side, becomes root, whole power 1 by 2. This is the answer for the question. You check the options which are given in this form. So in this case, this is 3 sine theta plus 2, right? Check the options which are there. Sine theta by 3 sine theta plus 2 whole power 1 by 2. Sine theta by, okay, 3 sine theta plus 2. This fourth option, if you observe that one, it is similar to that what we obtained. So answer fourth option is correct for this question. Last question of this one, this is related to current electricity. They given circuit diagram, they're asking to find the current passing through the battery. So this is a battery of 5 volts. They're asking to find the what is the total current in the circuit. I value is equal to 1. So current I is equal to, according to Ohm's law, V by R. V by R. In this case, we are not having one resistor, we are having number of resistors. So we have to find the effective resistance of the circuit. That is important for us. How to find the effective resistance of the circuit? When we are observing the circuit, first you look at this one. This is the circuit where it look like one of the Wheatstone-Bridge construction. Okay, so 4 resistors and diagonal there is a resistor. It look like a Wheatstone-Bridge construction. So check the balancing condition of the Wheatstone-Bridge. In this case, this is, okay, one of the resistor 5 and this is 3. Both are diagonally opposite of this one. So 5 by 3. That is according to the Wheatstone-Bridge condition, P by Q is equal to R by S. If it is satisfied, then you know that across the diagonal the IG current value is equal to 0. In the same way here also 5 by 3, P by Q means this is 5 by 3 is equal to, okay, 2.5 by 1.5. Check it that one. 2.5 I can write as 5 by 2. 1.5 I can write as 3 by 2. So 2 to get cancelled means what you are going to get? 5 by 3. So this is looking like a Wheatstone-Bridge. When it is look like a Wheatstone-Bridge, A point, D point. So that means potential at A point will becomes equal to potential at D point according to Wheatstone-Bridge condition. That means the resistance across this path, okay, the resistance across this path will not be effective in the circuit. So I can eliminate this one. After elimination, I can redraw the diagram, okay, using the like this. If we redraw the diagram, what is the circuit we have? This is the resistor of 1 by 3 ohms and along with the battery, and there is a resistor of 5.5 ohms here is connected, and there is a resistor of how much, that is 1.5 ohms resistance, and that will be connected to, as you're looking like this and here. So there is no resistor connected between. This is the resistor. We can take one resistor here and another resistor here, and after that one, this is one more resistor here, again one more resistor here. This look like, because we removed the resistance between C to D, sorry, not C to D, A to D. This A point, D point resistor we removed because according to Wheatstone-Bridge condition, there is no current across that one. There is no effective resistance of this circuit. circuit. So if you observe this one, now how to solve this one? If you observe these two looking like in series, these two looking like in series, solve the effective resistance of these two. This value is how much? 5. This is 3. The effective is 8 in series. This is 2.5. This is 1.5. Effective series 2.5 plus 1.5 is 4. Now these two, okay, if you observe this one, okay, blue color I'm taking, this is both are in parallel combination. If you take in parallel combination, one is 8, one is 4, both are parallel combination. What you are going to get, that is 8 into 4 by 8 plus 4, that is nothing but how much you are going to get, that is 8 into 4 by 12, you are going to get, that is nothing but 8 by 3 ohms. You get this value is going to get 8 by 3 ohms. Now finally, if you reduce the circuit again, the final circuit is going to, I can put it on, this is one resistor and second resistor and third resistor, and finally we have only one resistor, that is effective resistance, okay, of these totally is this 8 by 3, and this one is 1.5 ohms left, and this one is 5.5 ohms left, and this one is 1 by 3 ohms left and connected to 5 ohms. Now this 1 by 3, this 1 by 3, 8 by 3, 1.5, 5.5, all are connected in, okay, first what base they are connected. If you observe this one, they are connected in the circuit. How they are connected? If you observe this one, all are in series, and that series resistance is connected to battery here. All are connected continuously, so they are connected in series. So series means 1.5 plus 1.5 plus 5.5, that is 7 plus. So total effective resistance in the circuit is equal to, I can write as total effective resistance is equal to 1 by 3 plus 8 by 3 plus 1.5, I can write as, okay, you can write as 1.5 plus 5.5. These are all connected in series. If you calculate this value, how much you are going to get? 1 by 3 plus 8 by 3 is 9 by 3, that is 3 plus 1.5, 5.5, that is nothing but 7, and totally 10 ohms. Effective resistance we have got 10 ohms. So the total current in the circuit is equal to total voltage by total resistance. Total voltage, how much we are applying? 5 volts. So this is 5 volts by total resistance, how much? 10 ohms. That means how much you are going to get? You are going to get 1 by 2, otherwise 0.5 amperes current. So the current which is flowing through the circuit is equal to how much? 0.5 amperes. So in the option, second option is correct, that is 0.5 ohms. So this is the solution for this last question. So NEET 2025 question paper is completely over. If you want any questions for the, okay, all the questions, you can check the, okay, remaining videos also, part 1, part 2, part 2A videos, and this is 2B video. These 4 videos contains all 45 questions of explanation you can have in this. If you have any doubt in this, you can able to comment so that I can able to explain that one detailedly if you require any explanation for this concepts. Okay, thank you for watching.